Today we are going to do section 2-2, direct variation. You will be able to write and interpret direct variation equations today. So you can write a formula for direct variation function as y is equal to kx, or y over x is equal to k. So these two equations is what we're going to focus on this section. K can never be equal to 0. So this formula, y divided by x is equal to k, says that except for 0, 0, the ratio of all output to input pairs is equal to some number or constant k. K is also called the constant variation. So we are going to identify direct variation from a table. We are going to determine whether y varies directly with x. If so, we want to, and we need to find the constant variation and the function rule. So we need to remember our equations from the slide before. Y is equal to kx and y divided by x is equal to k. So I'm going to look at this second equation, y divided by x is equal to k, to see if for every ordered pair we have the same k value. So 2 divided by 1 is equal to 2. 6 divided by 3 is equal to 2. 8 divided by 4 is equal to 2. Since all of these k values are the same, we then have k is equal to 2. Since k is equal to 2, we have constant variation, and I can write my rule using my first equation. Y is equal to 2x, since k is equal to 2. Now let's do the same for b. 4 divided by 1 equals 4. 8 divided by 2 is equal to 4. 11 divided by 3 does not equal 4, therefore this is not, y does not vary directly with x. Here we need to identify direct variation from equations. So once again, remember your equations from the first slide. Y is equal to kx. And we want to see if we can make our equations in that form. So I'm going to solve for y. Divide by 3. Y is equal to 7/3 x. Since this is in the form y is equal to kx, this does vary directly, and k, or constant variation, is equal to 7/3. Then we're going to try b. I'm once again going to solve for y. So I'm dividing by 7, and y is equal to 14x divided by 7 is 2x. 7 divided by 7 is plus 1. Y is equal to 2x plus 1. Since we have that plus 1, we are not in the same form, y is equal to kx. Therefore, y does not vary directly with x. We also may need to use a proportion to solve direct variation problems. So suppose y varies directly with x and y equals 9 when x is equal to -15. We want to know what y is equal to when x is equal to 21. So what we know right now is y is equal to 9 when x is equal to -15. We also know that y over x is equal to k. We need to know what y is equal to when x is equal to 21. So we're going to set up a proportion. 9 over negative 15 is equal to y divided by 21. And we can simplify our first fraction by 3. So this is going to be 3 over negative 5 is equal to y over 21. I'm going to cross multiply to solve, so 3 times 21 is 63, which is equal to negative 5y. Divide by negative 5 on both sides, and y is equal to negative 63 divided by 5. And lastly, we can use direct variation to solve a problem. So if a sales commission varies directly with sales, so for $1,000 in sales, the commission is $85. We want to know what is the commission for $2,300 in sales. We're going to once again set up a proportion. We know that y over x is equal to k. So both of these proportions of y to x need to be equal to the same number. That's why we can set them equal to each other. So I'm going to have $1,000 in sales to my commission of $85 is equal to $2,300 in sales is to how much commission? So we are going to do cross multiply once again. 1,000x is equal to 2,300 times 85, which is 195,500. And I'm going to divide by 1,000 to isolate x. Therefore, we would get $195 in commission. Good job, guys.